If you don't know what it is, you shouldn't be here.
This is your bag, right? Sorry about the delay. I seriously was.
Okay, we'll start now. Thank you very much. Please go to your seats and start checking your email. Okay. This is TRAM. What time is it now? Yeah, we should start. Note well. Logistics, do we have a minute taker, please? Anyone will do. You will get a nice star, the color of your choice. In addition, we need a jabber scribe. And the jabber scribe will also get a star the same color as the minute taker, but the minute taker gets to choose the color. Jonathan, what's the color of your star? Magnus, you want to take notes? Rough notes, just action items. Thank you. What color? Okay. Okay, this is the agenda that we have. So we have 2 sessions. And today we're only going to do the left side. So we're actually going to start with stuff that isn't currently working group drafts. Is anybody against that, or would anyone want to add stuff, change stuff? No? Okay. So state of the TRAM. First, we have 2 documents that have been with the IESG. First one is third-party authorization that had 3 new revisions. It has just been approved by the IESG and is now with the RFC editor. Stun Origin has had a different course. It was not approved by the IESG on grounds of privacy. The big problem is that a stun or turn server now can learn what web application you're using in the case of WebRTC, for example, without having a relationship with the application or with the user. So significant changes will be necessary if we're to go again at the IESG with this idea. And it is to be discussed in the second TRAM session. So next, that's all I'm going to say about this. Working group drafts. Turn Server Discovery has had a working group last call and has received comments from Ted Hardy. In my view, they were good comments, but will not require a significant architectural change to the draft. Yes?
We'll just fix that and I'll publish that tomorrow morning.
So you're going to publish this?
Yeah, I'll
Okay.
address Ted's comments and publish
And
them.
we have just received like this amount of comments.
From Carl.
Yes.
I will probably look at it later this week and try to
Okay.
address them.
So the ball is in your camp.
Yeah.
StunBIS and TurnBIS have had new revisions. Yes, Mark?
Yes, so about StunBIS, we still have two things to add to StunBIS, which came from the work we did with HTTPOS, and one of them is to add vectors for the new password hash inside the example thing. And second things which we never talked about is that there is something nice which was done in HTTPOS, which was to hide the username, a way to hide the username which is sent. So the idea is to copy, in fact, what was done by Rifat on his draft. His draft is on the RFC editor hands, so it's safe to do the same thing here. So we will work on this as soon as possible after the IETF mid-meeting and publish a revised version, which hopefully we will receive a lot of comments, so we can go to working group last call.
On the authentication scheme, does that mean that turn servers and web servers will be able to, speak the same language? Will they have pretty much the same authentication scheme?
Yes. The idea is that we copy as much as possible from what HTTPOS did. So we have exactly the same database, and the same logic is done for both.
Awesome. All right.
So sorry, my co-author, we really need reviews. We received absolutely nothing since Dallas, so we really would like to have reviews, not like we had in IVT Core 2 weeks before the meeting.
So StunBIS in particular, right?
Yes, I'm talking about StunBIS.
First priority will be StunBIS for reviews, please. Anybody wants to raise your hand? You will also get a star of the color chosen by Magnus.
Wait, I'm putting my hand down now. The color yet.
Yeah, it's a blank check. But one of them is really ugly. But Magnus has to wear it as well. Okay, so Brandon, thank you very much. You will review StunBIS. Sorry for this. So anybody else, even if you didn't raise your hand, please review StunBIS. Stun path data was adopted last time, and it has had one additional revision. And it is now being considered for being part of a measurement framework. Sorry? It's not projecting. Oh. Sorry. I'll try to move my mouse every 30 seconds, which is the ice timer. Okay. That'll do. So yeah, it's being considered for a measurement framework, and we will have more information about this in the next presentation. Is this all I need to say? Yeah, that's it. So next up is stun trace route.
I just had a quick question on the
Yep.
thing that was mentioned about the username hiding behavior. This is Justin Brady. Is that applicable just to turn, or is that applicable to stun and ice as well?
Did you understand the question?
What was the, I'm sorry. What was the question?
I was assuming that it was about what the thing that we were saying we were taking in TRN-BIS from HTTP2 to allow the username to be hidden from a network eavesdropper. And I'm wondering, is that turn specific, or would this perhaps also be applicable for ICE?
It's applicable for every stun usage that are using the authentication mechanism. Long term, yes. Only long term.
Right. But not the short term.
Yes. Well, when you use turn with ICE, then yes.
So Mark, stay there for a second. How do you propose that this be negotiated? Because HTTP has a negotiation mechanism, whereas stun does not necessarily. Oh, you actually intend to use that?
I have to remember.
You need to use hash or whatever it is.
We use. I have the
okay.
draft of the draft somewhere. I honestly, from top of my head, I cannot remember. But yes, there is a negotiation that the server knows that it can use it. And I copied exactly, not the same bit, but what HTTP is doing.
I just want a clarification on that. The concern that I have is that that's going to be trivial to remove. And it's not clear that protecting a low entropy secret in that fashion is actually useful.
So the reason I'm doing this is because HTTPOs like it, right? So they probably knows better than me. So okay.
Justin Brady, I mean, I think this is generally worth protecting. I think you can still obtain substantial information from an encrypted WebRTC thing with usernames. Given the fact that ICE does have message integrity, I wonder if it would be possible to also use this for short-term authentication as well.
It's worth considering. So I will publish, okay, let's say in the next month, I will publish a version that will have this, and then we can discuss from this point, this time, how we can. So the thing with short term, especially on ICE, is that the password is already a random thing. So there is not much information you can extract from this, right? On ICE.
Sorry, I missed that.
On ICE, with the short term authentication, this is already a random string. So there is not a lot of information you can extract from this. The difference of the long-term authentication, where you're using a username which is relatively easy to match to a real user.
Sure. You can already do a lot of, we found ways of doing a lot of sort of semantic analysis based on what the length of usernames are that are included to identify what the clients are that are being used. And there's actually substantial, like, you can get a decent amount of information from this. So anyway, you know, that seems like a good proposal. Let's get the new version published, and we'll see if it makes sense to do it for short term.
Yeah. Okay.
Hi, this is an updated draft for the stun trace route we presented last IETF. Next slide. So the changes are, we did simplify a few things in the draft by removing some network feedback, which probably would not happen anyway. Added code examples for Windows, C-ish pseudocode. And we removed and probably added a few errors and spelling mistakes and whatnot. Next slide. And for you who don't remember what this is a way to do trace routes without admin privileges on the media path, on the accurate media path where we're actually sending the RTP packets. And well, it gives you RTT for each hop, sort of, and it will include some good packet loss indication and where it happens in the network. And we actually implemented this in a few of our products to be able to better debug what's happening when media isn't flowing as expected. Well, we are going to ask for adoption, but we probably need to have the framework, whatever, discussion first. Questions?
That was quick. So let's do the next one.
So this is a method an endpoint or whatever device can use to probe its bandwidth capabilities before doing any call, if it has a turn server available. So next slide. Well, there are some property stuff. Next slide. So how? Well, Alice wants to test her network. And next slide. She does allocate a turn relay address as usual. Also learns her reflexive address. Next slide. And then she actually sets the permission on the allocated turn relay port to allow packets coming from the reflexive address. Next slide. That allows Alice to send data to the allocated relay port. Next slide. And receive data on that. So you have a circle. You can send packets and receive them, and then you can do bandwidth probing. Next slide. So why? Well, it's a simple reuse of turn infrastructure to get a hint of network capabilities before the call. There are no real interrupt issues because the client can determine the packet interface it sends, because whatever it sends, it will get back. And we have actually used this in products for a couple of years now. Next slide. So potential issues that might be worth discussing is today we don't really provide much detailing in the probing packets, and that's on purpose. Should we have more detail there or not? More guidance on how to send the probes, not to trigger unnecessary buffer bloat or whatnot might be useful. And today the draft is marked informational because there's no real interrupt issues there. So, any comments on that would be good. Next slide.
Yeah, question. You say here no interrupt needed to support this. Don't you request an IANA code for this?
What? That's the question. We did specify a little bit in the drafts today on the packet format, but should we? Should it be more, less? Depends on how extensible we want it to be.
Justin, you ready? So, like, extending the turn protocol to do this seems kind of weird to me because it means that this thing is explicitly sort of specified only to use with turn servers. And if you send like generic packets, like data channel packets or RTP packets, then the same mechanism could be used for like loopback testing as well as testing like end-to-end, bandwidth. So it seems a little weird here that we would sort of mandate that the actual bandwidth probe mechanism be done using turn packets, and we've seen like we already do this sort of thing in web applications right now by sending like datagram packets of increasing or data channel packets of increasing size. We could give some sort of best practices for how to do turn server bandwidth estimation using various packets, but I don't think sort of specifying the wire format here is all that useful.
I think I agree on
that. Stay up. So when you do this end-to-end, how do you ensure interrupt?
I mean, like both sides have to be kind of aware they're participating in this.
All right, so meaning they're both Chrome, right?
Well, the point I was making about this is that a single application with no changes to the underlying browser implementation can do this right now by sending data channel packets to the turn server, which automatically will be looped back because it'll specify itself as a sender and receiver. So you can do this right now.
At the application level?
At the application level, yes.
Okay.
Now, obviously, if you want to do this between two endpoints, they need to sort of, in JavaScript, or, over, their own signaling channel, tell them, the other side that get ready to receive a bunch of bandwidth information and send it right back to me as soon as these packets come in.
Right. So the advantage I see of doing this at a lower level than the application level is being able to pick an ICE candidate that has the best characteristics. So if you measure things at the browser level without the application knowing, and you can do this end to end, that's great. That means you can nominate the candidate that you want.
Sure, but wouldn't you want to test the actual candidate pair that has the best bandwidth flow rather than just the turn server candidate that has the best one?
Oh yeah, definitely. Yes.
So that kind of says we want to do this in a packet format that's not turn packets, it's some other type of Fellner packet.
Probably, I don't know. I'm just thinking about, this is one way to measure things, right? This is kind of one input into the algorithm that will decide what we end up using, right? If you know that this turn server is pretty good, then you might want to use it.
Well, the intention of the draft is just to learn something prior to the call, like what kind of link am I on, what can I expect, and then you run ICE and pick whatever. And some of the packets would probably traverse that link anyway, at least.
Sure, but are we intending this as like a debugging tool, like the trace route is, or are we intending this as something that would really be exercised against every turn server you're using across every interface you're using pre-call?
I haven't thought about the multiple interface story. The way we use it today is we use it pre-call once in a while. Once endpoint register to the zip server, it will do this just to get an estimate of the bandwidth available and set the call bandwidth accordingly and then rate adapt to that. It's just to get some kind of hints on what the network capabilities is.
Okay.
It's not meant to be end-to-end. Doing it end-to-end would also be very interesting to spec up. And then, of course, if you have the end-to-end specification, that end-to-end specification can be used here to send and receive to yourself.
Right. The part that just worries me is that we're including things like timestamp into the turn packet when we already have things like this at the RTP level. So we're like smashing stuff down, like, in the stack, so that we can do this in a fully self-contained way, where it actually might make more sense to just send like junk RTP packets to the turn server to do this, and we don't need to invent anything in order to do that.
Yeah, well, all this draft says really is open up relay port and set permissions to the reflexive address and then send data to measure. That's the core of it.
Right, but it's also inventing a little bit, right? Like, here's the actual junk you're going to send.
Yeah, we can. That's the discussion we're having now. Should that be there or should it be removed? Or for example.
I mean, I think the general concept is a good idea. I'm slightly averse to the idea of like, adding fields to turn to actually, carry like timestamp information that would typically be carried at higher layers.
I agree.
I'm just thinking how actually, in the WebRTC case, it has to be entirely in the browser with no JavaScript intervention. I think it would have to be, because otherwise, how do you supply the server reflexive address, right? Because you can't trust the JavaScript to tell you the server reflexive address. No, I think it's true.
Obviously, the browser, like if you're doing it pre-call, you probably just want the browser to do it and use it as some input into like its prioritization of which selected pair to use. If the application wants to have access to this, like if it allocates a turn candidate, then basically, if it uses the parameters to say only use turn candidates, it'll make sure that like the data is routed over turn, and you're going to get this like loop back thing when you have both the sender and receiver on the same machine. It'll have to traverse the turn server. And so like the application can get access to the bandwidth that way. It's really a question of what we want to do. And if we use it as a general framework, which is kind of what is being proposed here, then either way could be used.
Cool. Thanks for the input.
Okay. Now we have a presentation on another measurement tool using stun.
Okay. PMTU discovery using stun. Next slide, please. So a little bit of history. This is part of my personal collection of drafts rejected by BAs that I tried to push again here. So this was proposed originally in 2008, and the idea was not really to do PMTU stun. It was to provide a way for UDP protocol who do not have PMTUD baked in to provide them a way to add this feature. So the draft was not, the working group was not interested at the time, and you can see it in the draft because I proposed multiple solutions in it, and the idea was the working group would choose something inside, and then we would continue this way. So you need to keep this in mind when we talk about other things. So one important thing is that it's not a path MTU for turn, for example. This is really a more generic fix. Next slide, please. Next slide, please.
Oh, sorry.
So this is a stun usage. The algorithm is entirely described in 4821. So we describe only the bit on the wire. We don't explain how to measure exactly the PMTUD because everything is explained in this RFC. And we do it only in one direction. Obviously, you can extend this by doing this in both sides, but this measure the path MTU only on one direction. Next slide, please. So there is two mechanisms. This is what I explained. A simple one and a way more complex one, and someone will have to make a decision about this. So the simple probing mechanism, send a probe request, which is a new message. We reuse the padding from 5780. We set the DF bit, and then we can receive an ICMP or I think we transmit for free time, and we can find the size. It's explained exactly in the draft how you match this with the algorithm in PMTU. Next slide, please. Okay, and there is a more complex algorithm, which is in fact collecting multiple responses and then keep track of the order and keep track of the retransmission and so on. So you can do, again, according to RFC 4821, can do a better job of discovering and a faster job also discovering a path MTU. Next slide, please.
It's fun that all your slides are slide number 2.
Okay. Yeah, so this is what I explained. So we create a list, we have a report response, and we send back the list of all the packets we received. Next slide, please.
It's multiple times 2. Page number is 2 and the item number is 2.
Okay. Yeah, so remember, this is also for other UDP protocols that are not stun. So I propose 2 mechanisms inside to be able to do this also for protocols that are not stun. One was to calculate a checksum to be able to recognize what packet was received and what was not received. Next slide, I think. And the other was to add a shim to have an identifier for this. Again, this is for discussion. This is absolutely not what we can do, and we need discussion. But this is where we left it back in 2008. Next slide, please. Okay, so like the 2 previous presentations, this is part of a general measurement framework.
Could be part.
Could be part of a general.
Not decided yet.
Okay. Question about this?
Does anyone have a use for this? Does anyone see this and think, yeah, we're doing this or we should be doing this?
Jonathan, yeah, I mean, I think for me, the use case is, I mean, we often have the problem for like video, you want to fill your MTU because the packet overheads are fairly high, and you're usually bigger than a single packet. But if you don't know the MTU, you have to be pretty conservative because there might be a VPN in the loop or something. So it'd be handy to be able to, for ICE to be able to get end-to-end path MTU so that you can yank your encoded slice size or whatever up to the maximum supported by the path safely. So yeah, I do see a use case for this. I mean, I guess the draft says how you negotiate whether your ICE supports it, but that's a...
Yeah, so the draft explicitly said that the destination need to know that it supports this. So obviously there is a piece missing, which is in ICE to have a flag, something that is out of scope for this draft.
Jonathan, I mean, another question is that ask whether that's actually true, or could you, by not using this comprehension mandatory padding, but a comprehension optional padding, just do it, pretend it's an ordinary consent check or whatever, and see if you get a response.
I think I again copied the recommendation from 4821, which is do not send probe packet if you don't know that the other destination is expecting probe packet. So we will have to weaken this in this case because this is a new packet format, right? It's not a new, it's not an attribute on the packet, an existing packet. This is a new.
Right. I mean, that's if you're doing it that way, then yeah, I agree. I mean, it seems like you could not do it that way, but maybe that's not a good idea.
You can piggyback the.
I mean, you could do like ICE consent or connectivity with a comprehension optional padding, and it would work. Maybe people think that's a bad idea because you don't want their policy reasons or something.
Justin Birdie, on the topic of 1 versus 3 documents, like this and the trace route seem like they go pretty hand in hand, just because they're both doing ICMP stuff and like they generally have a pretty common view of like how this actual process should work. I think the bandwidth one seems kind of different. So like I would suggest that we either do 3 documents or combine the PMTUD and the trace route into the same document.
Brandon Williams, Akamai. Is this one, I mean, my read of this one was, yeah, the thing in the middle produces ICMP, but the ICMP isn't actually being used in a meaningful way, at least for the end-to-end, right? This one, in some respects, seemed a little bit closer to the other in that it's not expecting ICMP to get through and using it that way. Did I misunderstand that?
Not sure to.
The draft talks about ICMP being generated. It doesn't talk at all about being able to actually use the ICMP in a meaningful way.
Yes, it does. So what the draft said is that you send a probe. If you receive an ICMP or if you retransmit more than 2 times, 3 times, then your probe failed.
But there's not. It certainly wasn't. It wasn't clear enough. It seemed to be indicating to me that you're counting on detecting that packets didn't arrive, as opposed to counting on receiving the ICMP, which I think would be problematic anyway. Counting on actually receiving the ICMP.
Well, again, the text is from 4821, which said you cannot count on the ICMP. If you receive it, right. If you don't receive it, you have to transmit.
Well, if all you're trying to do is just get the error, like that'll be returned from received from, so that you can just still get the error that you got an ICMP error packet without having to have like kernel level socket access. So like if you don't need any more details other than the fact that an error occurred, like you could do this all in user mode, and that would be a lot different.
Yeah. Yeah. Well, it wasn't clear to me from the draft how the information you would learn from the ICMP on the leg that's not. If there were a relay in the path, it wasn't clear to me how the information would get all the way back to the sender. The draft didn't appear to me to be describing. I learned this information from ICMP on the relay, and here's how I propagate that back to the original sender so it can use it in a meaningful way. So I assumed that it wasn't relying on the ICMP getting through, that it was actually fundamentally relying on other stuff.
You are right, in fact. And I remember now that you're talking about this, that I had an extension which permitted for the turn server to send back a message, an indication that said, I receive an ICMP. I remember now,
right.
sorry.
I learned that the MTU on the non-relay leg was this, and therefore here's how I propagate
and it was a complement of the fact that we set the DF bit in the other direction, right? So it works fine with turn because you receive directly the packet. Right. You're right. It doesn't work with when you are going through turn because the ICMP packet ends here. So you need one small thing, which is an indication, yes, that contains this. No, you are totally right.
And regarding the single document question, I think there's enough, in combination, there are enough areas of overlap among the various mechanisms, and the kinds of things that need to be specified, they're sort of in bits and pieces in the various drafts. I don't see any of them on their own at the moment as being complete as currently specified. If they remain separate drafts, I think they're all going to require a certain amount of redundant specification about how to do various different pieces to be able to take the information into account end to end, especially if we look at the one draft that currently is just focused on one leg of the path and look for ways to make it a full path measurement. That will require a bunch of stuff that would also need to be redundantly specified in the other drafts. So I think a single draft, if we're in agreement about all three mechanisms, would end up requiring less redundant specification effort and be a better unified thing as a result.
So you try to merge the draft right after the Dallas, so perhaps.
Subconscious. You sound really early to making this decision. I mean, I think the reason you should decide that you'd want to merge these or not merge these is if there's somebody who would want to implement one of these but not the other ones, you probably don't want to merge them, so they can say, I implement RFCX. And if anyone who is implementing one of these would definitely implement all of them or two of them or whatever, then it makes sense to merge. And that'll become clearer once you get closer to that. Like we're discussing the color of the bike shed here.
Good point. Yeah, let's not discuss merging or not. So let's. So I'm seeing definite interest into the Path MTU draft. Bandwidth probe. Is anyone interested in this beyond those who have already implemented this and are using it? Is anybody else thinking that they should be using it too?
I'm kind of curious about what the actual IPR declaration is on this before answering that question.
On PMTUD?
No, the bandwidth probe one.
I'm not sure how to answer patent questions, but for a while back, when we implemented it, some lawyers asked if we had any ideas that should be patented, and I told them, oh, we're doing this, and then and the thing is, if it's an RFC, you're free to use unless you harass us in some serious ways, I think.
Okay.
So
interesting.
That's one of my main motivations for writing this up as well, is because it kind of opens up. Okay. I'm not sure whether I'm allowed to say this.
Would anyone be opposed to the adoption of bandwidth probe? Does anyone think it's a bad idea or that it won't work? Is it informational or? It's informational. Okay.
Take taking advice from Justin by removing the packet information and just saying that the obvious thing, set permissions from your reflexive address, and then you can send packets and receive them to yourself.
Right. I mean, just that probably speaks also to like whether there should be one RFC or three. And like this one is informational and the other two are standards tracked, then like clearly that tells us what we need to do.
Yeah, good point. All right. Next one is stun trace route. So same questions. Does anyone think that this is cool and they should be using it? Or is anyone else already doing it? No? Is anyone opposed to the adoption? Does anyone think it's a bad idea or that it won't work? Okay, cool. That's all I had to know.
Okay, hopefully this will be brief and we can finish. Just as a recap of the changes between return that was presented at IETF 92 and the most recent version that was published that became a working group doc. Next slide. So the main thing that was changed was some changes to the security considerations regarding how auto discovery works or regarding how auto discovery should be thought about. Next slide. So, okay, Ben ended this. This is about how exactly what return is supposed to do. An enterprise deploys a turn server, and this turn server allows basically you to get out the same way that like a enterprise's HTTP proxy allows you to get out, or allows the client to get out to the web. Next slide. And this is kind of how it looks, from a diagram basis, that the HTTP proxy allows the browser to get out to the internet, and the return proxy allows WebRTC traffic, WebRTC media in particular, to get out to the internet. Next slide. So the change here is the security considerations, basically saying that a return proxy really has a lot of discretion over what happens to that media traffic. And if it wanted to, it could then start recording all packets, even if they're encrypted. It could record them with the hope of decrypting them later, or it could basically block flows that are going to things that it didn't think were the right destinations to go to. And this basically gives, as I said, the browser, this proxy a lot of discretion into whether it should allow traffic out or not. And this is something that might make sense if you're in an enterprise where there's explicit corporate policy about whether the traffic should go out or not, but you may not want this to happen to your on your ISP. Like you may not want to give your ISP control over whether your media should go out or how it goes out, the same way that you don't give your ISP control over like your web browsing traffic. Your ISP, you can't make your ISP force you through a web proxy. So this tries to basically rationalize how return works with how web proxies are typically implemented. And next slide. Okay. In any case, basically the mechanisms that are that's right.
So
parting thoughts. This is totally wrong.
No. I'm just saying that please don't use the current implementation of HTTP proxies to justify anything.
Okay, well, this is saying that this is worse than HTTP proxy before, so no, we're making it no worse than. If you think it should be,
that is not a good defense. Is my point. If you want to be no worse than an HTTP proxy, that's setting the bar too low.
Okay.
All right.
Anyway, the main thing is saying that here in the actual auto discovery draft that's currently going last call here in TRAM, it says the best ways of doing auto discovery are through MDNS and Anycast. And the security considerations that's been added to return says don't do that. That these things, it would allow somebody who happens to have access to the network to be able to force you to go through a proxy. And that's really not the intent of return. It's really the intent is that if you have enterprise control of the network, only then can you actually force someone to go through the proxy. So the return and the current auto discovery draft are kind of not on the same page at this point in time.
Yeah, Adam Roach, I'm actually a little concerned that you've defeated most of the use cases that at least I envision for MDNS being useful. I also, it brings to mind, you've probably seen pictures where you have like wide open fields with roads running through them, and someone's put a toll gate across the road, but it's open on all sides. The problem is anyone who's in a position to do this is in a position to do this anyway without using an MDNS advertisement of a proxy. If I'm on the same segment as you, I can throw ARPs at you. If I'm your ISP,
Sure.
Game over, I'm between you and the internet. There's really nothing you're preventing from happening here that can't be done via other mechanisms. And you're taking away the utility. So I think that we're paying a price with no benefit.
I definitely agree that the ISP is currently in a position to do this. Like it has your packets, it can do whatever it wants, but it doesn't do that. It's not inserting proxy configuration. But I want to hear what Colin has to say.
Well, I mean, I get your point that in some cases you're concerned about the attacker might be already on the path, right? But this allows at a Starbucks, what I don't want to have happen is you go to Starbucks and suddenly all of your traffic is, you know, routed through GoGo Wi-Fi's proxy.
But it's already going through the network. There's nothing saying they can't shut it off to start with.
No. It was going through Starbucks network. Okay. I'm not. So the difference here is if Starbucks wants to cause all of your traffic to be routed somewhere else, they could always do that with all of their traffic, and you'd be able to see what was going on, right? But this allows you to very easily insert man in the middle. It allows somebody who would have been very difficult to be an on-path attacker to suddenly become an on-path attacker in these types of scenarios and route the specific traffic they're interested in through someplace it wouldn't normally go.
So
I mean, what did Snowden say? There was a great Snowden quote on this the other night.
Can I see if I understand your concern? Your concern is, as I understand it, that if I control your network environment, at present, I can't selectively detour your traffic, and this would allow you to selectively detour only parts of it. Is that correct?
Yeah, to selectively detour it. And I mean, we wouldn't be very happy if the Starbucks suddenly forced all of your HTTP traffic through a given proxy either, right? That would also reveal stuff to that proxy that you wouldn't necessarily want to say.
But it already can do that, right? We agree with that.
No, I don't actually.
Huh?
I've heard this assertion made.
No, I mean, if you advertise proxy auto configuration, right?
Yeah, this is easy. I do it at home. You shove things through a squid proxy. Just you intercept port 80, shove it through a squid proxy, and it does all the stuff for you. You could do that at the router on Starbucks. You're not introducing.
This is why we're trying to get at.
Starbucks to do that.
This is trying to understand the threat model. The threat model is that I have some proxy which is off path to the user, but I control the network path. But I want to detour the traffic to the off-path proxy for processing. Is that the concern, Colin?
Right, and I don't buy Adam's assertion that this works fine that you can do this HTTP today.
I'm not taking a position on any substantive matter. I'm trying to understand your issue.
Yeah.
Okay, so how would you do that detour? You have to be on the local segment to do that MDNS response, yes?
Right, but I think Colin's point is that, like, I'm Starbucks and I have a contract. I don't know which way the money flows with like Evil Inspection Corp, right? And I have a WRT 54G on my access point, which can't do any inspection at all, but it can emit an MDNS response that says send all your WebRTC traffic over here.
How can you not do inspection on that?
Because then the point is that I off-source that to some other person who's off path on cloud rather than having to have an inspector local. I'm not saying it's bad or good. I'm just saying I think that's the idea.
Or I'm at Starbucks and I'm not Starbucks. I'm just happen to be on the same network at Starbucks. I'm sitting beside you at the guy at the other table, and I spoof a DHCP packet, which has the option that redirects you into this. I think that would be
or an ARP packet, and you're the router. I mean, there's all kinds of attacks on the local segment.
Try it at Starbucks. It won't work. Give us a number. ARP will not work. Will not work at most of those types of things. Yeah, the wireless client system. But MDNS.
So I was going to say the scenario I was concerned about was more DHCP than MDNS, but I suspect the MDNS scenario is the same. I just haven't tried it.
And just to be clear, the scenario we're talking about is both the person who's offering the network forcing you through the proxy as well as somebody who happens to be sitting on the same local segment, basically spoofing a response that sends you through the proxy.
Jonathan, yeah, I mean, I think that for me, the guy at the other table threat model is much more serious than, if you're on a network that's hostile, I mean, the fact that it costs them, we're doing something that, makes, something they could easily do cost a little bit less for them is not, for me, a terribly compelling thing. But I think, the other guy, the guy at the other table being able to do things to you seems to me a much more interesting threat model.
If I can spoof the HTTP responses, I can force you to a new DNS server, and I can do all sorts of garbage. I mean, like, either by hypothesis you can fuck with the DHCP or it cannot. But unless you're telling me I can fuck with some of the DHCP and not all of it, like, I just not understand. Now I'm confused about the threat model again. I thought I understood it, but now I'm confused.
I mean, I'm not sure that forcing somebody to the wrong DNS server really buys you all that much, right? Yeah.
It does, because
And then when they resolve, return.google.com, they end up at my pin.
So,
yeah, I mean, if I can force people to take my resolver, then basically I own them. I mean, 99% of the time, right?
Right. Well, all our return servers are specified with IP addresses because that's part of why. But
okay, that's not half. I know Google doesn't do it that way, and neither way.
Because load balancing is for wusses. I mean, there are good reasons to use DNS to do these kinds of things, and people are going to.
So Martin Thompson, my original point and the reason that I got up here is that we've had these long discussions about how people may or may not want to insert an HTTP proxy and how you might discover it. And it has never been the case that it is acceptable to insert an HTTP proxy without something of a higher bar than what's been established here. Now, it might be that MDNS is fine because it works in a different way to DHCP, and you can't spoof the DHCP, you can't spoof the ARP, but MDNS is a problem, and that introduces a different.
Another proxy not into DNS, so now you have a great.
There may be a case that there's like grades here that we haven't actually got a good handle on because we're not people who actually run these sorts of networks. But I just want to get back to the fundamental question, which is it acceptable to have someone insert themselves into the path in this fashion? And it wasn't acceptable for HTTP in all the discussions we had with it. All sorts of people. Why would it be acceptable here? Not that we're giving them that much, to be honest, but.
I mean, I got to say to that point, I mean, I totally agree with the text that's in the draft right now that we wrote it after last session that said untrusted, right? And I mean, if we can show that in the way we use it, we know MDS is trusted. It's only coming from some trusted. I mean, like, I'm not objecting to that. I'm just sort of saying untrusted, right? I think it's.
Yeah, and I have no problem with that either. And it's potentially if the router is on path, we consider it to be trusted sufficiently to perform this sort of attack, then that's fine, and that may be that the Anycast method is sufficient for that purpose, because the guy who's owning you in that situation is already on path in the first place, and could, in theory, at least do that owning if they had the resources. I mean, Eka's example was perhaps a little bit of a stretch on that, but that's something you might like to consider.
So, can you just re-summarize that for me? Like, the text as written here in security considerations, do we agree with this, or do we want to amend it to be less restrictive?
So I think that this is on users where, which can only be modified by. So Cullen's phrasing was, I think, right, which is that the must not use proxies that are provided by untrusted sources. Now, if we can find some way to say that using Anycast, for instance, was sufficiently trusted for this purpose, then we would make the exception for Anycast.
This isn't even addressing Anycast. This problem doesn't arise with Anycast.
I'm just using it as an example, right?
Oh, okay.
If we said that Anycast was sufficient for the purposes of saying that the return proxy is sufficiently trusted, whatever that means, then that would get a pass. But maybe MDNS does not. Maybe DHCP does. Maybe I don't know how many options you've got in there.
I think we're talking about Anycast, MDNS, and DHCP right now, and that's before we even go down the rat hole of like PAC or like WPAD or whatever. So
I'd allow this, John. Just reminding that if we're designing new mechanisms, then you can make any insecure mechanism secure by signing by a trusted party.
Signing it.
Adding a signature.
I was going to say, yeah, we'll have this signed by the .local authority. I mean, this is not, that's not really a solution.
I don't even know what that is. Okay. So the main thing we need to consider here is just like, of the mechanisms that are articulated in the auto discovery draft, which of these sort of meet this text? And I guess we probably should spell that out explicitly for the avoidance of further confusion. Okay. Well, it seems like we're out of time for said discussion. We can have that discussion on RTC Web. Those of you
5
interested.
minutes.
What's that?
5 minutes.
We still have 5 minutes. Oh, okay. Well, does anyone want to propose a straw man for which of those mechanisms should be considered, trusted or not? It sounds like, Martin, your suggestion was that Anycast would be fine. Sure. Well, let's start somewhere.
MDNS means anything that can put out 50 traffic can then spoof whatever they want to spoof. There's no authentication.
Sure. Right. So I think MDNS is certainly like on the other end of the spectrum of like probably not trusted, and Anycast seems like more towards like that probably trusted, and then DHCP like seems like it falls in the middle. Right.
If you could use the mic, check on going to.
Colin, what's your take on this?
So there's two forms of Anycast, right? One is you happen to stick an Anycast address in as your turn server in the JavaScript application that came down, and it goes and does whatever, right? That is at that point the application signed up for whatever happens to it.
Right.
People do that, right?
This would just be
this is compiling an Anycast address into the browser that it checks and sees if it gets a response. I mean, anyone on the local subnet can respond to that, right?
Right.
No, that's not how Anycast works.
Yeah. Okay. Fair enough. So you're saying the router would not be routed to it. It was so. I mean. Okay, so it wouldn't be out of a multicast space. It would be true straight up Anycast, not multicast.
Right, but this would be something that would be compiled into the browser itself.
So now we get to the question about, is the Starbucks router trusted? And I'm going to claim the Starbucks router is not trusted. That's not what I meant by trusted, but it's someone I had a relationship with and agreed to take something from. And if you think that thing can send me a proxy file and override the proxy settings in my browser, I just don't think that's true. We can work on that offline.
For that situation, if something's between you and the network, and your concern is that something's going to see all your traffic, it's going to see all your traffic. I mean, it's defined to be the same problem.
That's not my concern. Is not that it can see all my traffic. My concern is that it can redirect all of my traffic to an attacker if it's sharing. I know you're going to say that, yeah, sure, it can do that too, but that's surprisingly more difficult.
So what would the redirection accomplish? Are you talking about increased latency? You're talking about this thing stored? Because again, WT454G, I can show you how to make sure that stuff ends up stored. This is not a hard thing. This is not a hard attack to mount.
I think I would also benefit from a more concise statement of the threat model here. If you could manage to write something that was relatively short that explained the difference between the concern you have here and the concern that and what the attacker can do merely by controlling the router, that'd be very helpful to me. I'm not saying this is invalid. I just don't understand it.
Yeah, that seems like a good way to have a more productive discussion. They table this, get a threat model, and then decide which of these mechanisms are actually, considered to be good or not good in this context.
All right. Have you had enough feedback?
I believe so.
The tram has spoken in one unanimous voice. Okay, thank you very much.
Where are the blue sheets? Okay, one is here. The other one? Blue sheets. Blue sheets. Hey, where are the blue sheets? Okay, I'm gonna go.